Hi everyone, this is the final video for our final project. My name is Bo
My name is Sai. The other teammate is Zhu Guang.
and our project is about movie recommendation system with chatbot. First, allow me to introduce our background. The movie industry has been flourishing at a significant speed. The increasing number of audiences has made it essential to precisely recommend movies for users. Our goal is to design a machine learning based algorithm for a collaborative filter system, movie recommendation system with front end virtual chatbot implementation. The reason we choose to implement chatbot is that it has 24/7 availability and it helps to minimize human errors, and it also reduces operational costs.
And for the data, we used two sources. The first one is Netflix. The second one is Movie Lens. And at the first stage, we used Netflix data to implement the Pearson analysis model and the collaborative filtering. But the limitation of this one is it has a very small amount of information and impossible to classify the movies and recommend a specific genre. So we move on to the Movie Lens for the further implementations like the model of SVD and the collaborative filtering with the cluster-based implementations like KNN. And for the methodologies, we use the memory-based collaborative filtering to make recommendations to the movie users. And the technique is based on the idea that users similar to one can be used to predict how much the other one would like the particular genre and the movie and having been watched by the second users too. And for the user to user collaborative filtering, here we find the look-alike user based on the similarities and the recommendation for the movies which first user look-alike hasn't been chosen in the past. And this algorithm is very effective but take a lot of time and resource to process. And the item-to-item collaborative filtering is quite similar to the previous algorithm, but instead of using the user's look-alike, we are trying to find the movies look-alike. And this algorithm is far less resource needed and time needed than the user-based one. In either scenario, we will build the similarity matrix. For the user-to-user collaborative filtering, the user similarity matrix will consist of some distance matrix that measures the similarities between any two pair of users. Likewise, the item similarity matrix will measure the similarity between the two pairs of item 2. And from the three distance similarity matrix, we use the Pearson similarity in these implementations for the diversity purpose. And I use the pairwise distance function from the sklearn to calculate the Pearson correlation coefficient here. And next, besides of the collaborative filtering model, we also have the model-based collaborative filtering, which is the matrix factorization, which is SVD. We here need to apply a dimensionality reduction technique to derive the taste and the preferences from the raw data. Otherwise, it also known as like doing low rank metric factorization. Since in the first model it doesn't scale particularly well to the massive datasets, and especially for the real-time recommendations based on the user's behavior similarities, which take a lot of computation. Additionally, the rating metrics may be overfitting to the noisy representation of the user taste and preferences, so we here wanted to use the SVD to discover the hidden correlation or features in raw data and also remove the redundant and noisy features that are not useful, which when we're using the SVD, it's easier to interpret and visualize the data. And here we just try to find the recommended movies for the user with the ID of 1310, and here's our output. And they look like a pretty good recommendation too. And for the last model we leveraged here is the KNN. This is the cluster-based algorithm, which is quite similar to the memory-based recommendation systems. In the memory-based one, we use the similarities between the user and item and use them as the weight to predict a ratings for the user and item. But here the difference is this approach are calculated based on a unsupervised learning model rather than the Pearson correlation or cosine similarities. And here the correlations are showing that overall ratings and individual ratings are not so correlated as individual ratings might be skewed. When the k equals to 1, the Cannon's classifier achieve the maximum accuracies too. And here are the evaluations we performed from the three type of systems, and we would recommend using the collaborative filterings with the Pearson, R analysis, and SVDs for the final output.
And as for the system part, our chatbot is our implementation. In our vision, our bot is a part of a personal video database, so our implementation with Lex and recommendation algorithm should work seamlessly to provide the user with a fluent experience. So when implementing the system, we were aiming for completeness from web page to backend functions. Our dialogue robot has two modes. The first is when our user already has data in our system. We will make recommendations based on the data collected from the chatbot and combined with the currently known user data. When the user is new to the system or there is no data on his or her account, we will enable the second mode, which is to use the chatbot to directly collect data and then put it into the algorithm to find the best match for the current data. The interaction logic between our dialogue robot and user is as follows. It basically collects slots and sends them to our recommendation model seamlessly. Here is a small demo of our project. And it gives out the recommendation from the recommendation system. And as for the implementation part, we utilized Amazon Web Services to deploy our robot. We used Amazon S3 and CloudFront to host our front page, and Amazon Lambda functions as middlewares to connect between the parts, and Amazon Lex for implementing conversational AI, and API gateway for receiving and transferring the messages delivered from the front page. And the tricky part of the system is to set up the Lex intent and align the JSON format of the components in the Amazon Web Service.
And next, we're moving on to the business value of our project. So from the operational perspective, it's an implementation as an add-in on the movie platform. It helps to filter and predict only the movies that corresponding users is most likely to watch. And the function of this chatbots is providing interactive user experience, reduce fractions, and streamline the finding movies process. And also from the cost perspective, it saves labor for optimizing the system and also streamline the personal experience for each user. And in the futures, we can also expand data sets to do like natural language processing or the deep learnings in the future. Thank you. That's all for our presentation. Thank you.
Thank you.